Hello. In this video, I will be walking you through all the steps that you need to know to get started with Proxmox Launchpad. Proxmox Launchpad is a CI/CD pipeline tool hosted on GitHub Actions that allows you to update your containers based on your repository code right from GitHub. For example, when you create a new branch for the first time, or you push code to an existing branch for the first time after you configured this GitHub action, Proxmox will automatically spin up a new container for you. And if you have automatic deployment on, your application will be automatically deployed as soon as the creation process is finished. This allows you to have multiple different containers, one for each different branch that may be in different stages of development. If you create a pull request to merge one branch into another branch, instead of developers or reviewers having to go on their local machine and fetch that new content themselves, they can just use the link provided to your container for that branch and see the deployment themselves. This makes it a lot faster to review different progress being done on different branches publicly. And at last, if you delete a branch, or if you successfully merge one branch into another branch and that branch is no longer needed, once you delete it, Proxmox or the GitHub Actions will actually automatically delete that container from the Proxmox cluster and any associated GitHub runners from it. This video will be divided into 3 parts. The first part will be actually setting up our initial workflow file to be housed on a repository and learning how to actually configure or to use this GitHub action in that workflow file to begin spinning up bare bones LXC containers on our Proxmox cluster. The second part will actually build off the workflow file that we built in the first part, and for a single component application or a repository with a single service running on it, we'll learn how to actually automatically deploy your application on LXC containers inside Proxmox. And the third part will be an extension of the second part, only the only difference being is that it will be designed for repositories with multiple components or multiple services running concurrently, and how to actually deploy those applications as well. So if you're watching this video for the second or the third part, make sure to watch the first part as well, as we'll be setting up the template for the workflow file. Alright, so let's get started. So for the first 2 parts of this video, I'm going to be using this repository called Rank Room. It's a simple application that creates different rooms for teams to help make decisions. That's not the important part. The important part will actually be configuring our workflow file with the GitHub action. So I opened up a new Visual Studio Code window and I cloned my repository onto my local machine. After ensuring that everything is up to date, we can begin creating our workflow file. So an important thing to remember is when you create a workflow file, it has to be housed inside the .github/workflows folder. If it's not, GitHub will not actually be able to find that workflow and it won't be ran. So make sure to create a .github folder and then create a workflows file inside that folder. Make sure to place all of your YAML files inside the workflows folder. Once you have those folders set up, we can begin creating our YAML file or our workflow file. So if I go here, I'm just going to create a new file, and I'm just going to name it container management.yaml. So at first, you might see some errors. That's just because we haven't actually written anything yet. But once we begin to start filling out this workflow file, the syntax checks should check out and we should all be good. So the first step here is to actually give our workflow file a name. So I'm just going to name it Proxmox Container Management. You can name it whatever you want, but just make it something that you'll remember so that when that workflow is running, you know which workflow it is. The next step is really important, as we're actually going to list all of the events that we want our GitHub action workflow to trigger on. So in our case, we want it to trigger on a push, we want it to trigger on a create or a branch creation, and we want to trigger it on a branch deletion. So to write that, we're going to use the on keyword, and then we're going to indent and we're going to write push. And we're going to use another field called branches, and we're just going to use all branches here. If you only want it to work on certain branches, you can do that too, but I'm just going to have it work on all the different branches. And then next we're going to write create, and then finally we're going to write delete. Again, don't worry about the red squiggly marks yet. It's going to keep throwing those at us until we have every single field we need for our workflow file. So the next step is to actually set up a few jobs for our workflow. So the first job is going to be to actually set up a runner. All right, so just a quick primer on why we actually need a setup runner job. So when we actually run this workflow file, we want it to be housed on a self-hosted runner actually inside of our container. So each of our containers that we deploy should have a self-hosted GitHub runner that's actively listening for jobs. However, it's sort of a catch-22 because how are we supposed to use our GitHub runner if we don't actually have a container yet. So the whole point of this first job is to actually set up a runner using a runner that GitHub supplies, and that runner will run a few scripts to set up our container and to actually set up our self-hosted runner, so that in the next job we can use that runner that is actually housed on our container to install all of the dependencies on our container to automatically deploy our app and other things like that. So it's sort of a two-step process. We have to actually construct our runner before we can use it. But once we do that, we should be all good to go to actually begin managing our container. And that will be the second job that I'll show you in just a second. But for this first job, the first thing we want to specify is the OS that it's going to run on. So I'm just going to run it on Ubuntu latest. I don't think it matters too much, but I would just stick with Ubuntu latest. And then we're going to use an if conditional. So this conditional is going to ensure that when we create a new branch, the GitHub action workflow is not going to run twice. So if a new branch is created, it's going to run. And also if there's a commit, it's going to run. So when you create a new branch, sometimes both of those things happen at once, and it runs two separate instances of the workflow. So we just want to put this conditional to ensure that that does not happen. So the conditional is actually if GitHub event and then underscore name does not equal push, or if GitHub event created equals false. And we're just going to put another pipe symbol here for or. Next, we're going to specify all the different steps for this specific job. So we're going to write steps, and then underneath steps, we're going to write the name of our first step. And the first step is actually going to be to install some dependencies on the runner supplied by GitHub. And after putting our name, we're going to put a run field, and this is where we're going to put the run commands to actually install these dependencies. And the two dependencies that we're going to be installing is SSH pass and JQ. SSH pass is used to actually SSH to a container that requires a password authentication. So this allows us to actually pass in that password to be authenticated. And JQ is a really useful library with so many tools for managing and parsing JSON data. Once we have all of those dependencies installed, we're going to add one more step inside of this job. In this new step, we're going to actually use our GitHub action, which is the Proxmox Launchpad. So to actually use it, we're going to go back to our Proxmox Launchpad GitHub Actions page here. And if we click use latest version, it's going to give us a command to actually use this in our workflow file. So all I have to do is copy this. And by default, it's going to give you the release version for the latest version released, but I'm going to switch that, and I'm just going to put that as main branch. So that way we always get the latest updates, even if it's not part of a new release yet. And by specifying this GitHub action workflow here, we're telling our local workflow file to run all of the commands inside of this workflow file. So there's a lot of logic in there, and I'm not going to go over that, but that's just the core script for creating and managing these different containers. However, there's one more step within this particular step, is we have to provide some parameters in order for the GitHub action to work. So what are these different parameters? Well, a lot of them are actually information about our repository, and then some are basic information about the container that we want to create. So I'm going to go over them one by one. So our GitHub event name is going to be the first one, and that's just going to tell the workflow file which event triggered this workflow to run. Second is just going to be our GitHub repository, so just the name of our repository. And the third one's going to be the owner of the repository, so that should just be your username. The fourth one is actually the branch that we're triggering this event on. The fifth and the sixth one is our Proxmox credentials, so we have our Proxmox password and then our Proxmox username. The seventh one is actually a password for our container. That could be anything that you want. Eighth is going to be the Linux distribution that we want to run on our container. So right now, Rocky and Debian are supported. The eighth one is actually your GitHub personal access token. And this is going to be used to actually configure the runner and then remove the runner later on. But we do need this token in order to create that runner. And then the ninth one is just a simple flag. It's called create runner job. And that just tells the workflow file the sole purpose of this job is to actually create a runner. And as you can see here, a lot of these values I do have as repository secrets. And I think that's very important because some of this is sort of confidential information. But right now, after you added all this, these are actually all the information, all of the steps needed to actually create a runner on our container. Now the second job is actually going to be managing that container. So installing all of our dependencies, cloning our repository if we have that, everything else we need to actually manage the container automatically. So I'm just going to call this job manage container. put a colon. And then the next step is to actually put the runs on. So instead of actually specifying the operating system like we did in the first step, we're actually just going to put self-hosted. And this will tell our GitHub repository to just use our self-hosted runner that we created in the last step. And that self-hosted runner is going to run on Debian. If you specified Debian, if you specified Rocky, then the runner will run on Rocky. Next one is important. It's actually going to be a needs field. And that needs field will tell this GitHub job not to run until the first GitHub job is done. So in this case, we don't want to run manage container unless the setup runner job is completed, because we're not able to run on a self-hosted runner if we don't have that runner yet. So I'm just going to write setup runner here. We're also going to copy the same conditional statement from the first job just to make sure that this workflow is not triggered twice when a branch is created. Next for our steps. So this time there's actually only going to be one step, and it's going to be using that same GitHub action called Proxmox Launchpad with mostly the same parameters, but we're going to pass a few more parameters too, and I'll show you those. Okay, so I just went ahead and added all of the dependencies for this job, and you'll notice that the first 10 are actually, or excuse me, the first 9 or 10, I'm not sure exactly how many it is, but they are the same as the dependencies we listed above. So all you have to do is just copy and paste these in the step right here. The only 3 we added, and the first one is actually optional, is a public key. So if you want to pass the public key from your machine to your container, this will allow you to automatically authenticate into your container when you use SSH. It's more secure and it's more efficient, but it's not required. The second argument is actually the HTTP port that we want our container to listen on. So all incoming HTTP traffic and other protocols that are based on HTTP will come in through this port. And the last argument is that same flag that we used in the job above, and it's going to be that create runner job. This time we're going to set that to end for no, because we're not actually creating a runner in this job. We're actually going to be using the runner we created in the last job. All right, so now we actually have everything we need in our workflow file to begin spinning up LXC containers in our Proxmox cluster automatically. Just a few things to note here. Make sure that you spell Ubuntu correctly. I accidentally misspelled it, so hopefully you spelled it right, or else it won't run. And then also include this -y flag after the install part of the sudo command. This just allows the runner to install these dependencies automatically without asking for verification to install them. But after that, we should be actually ready to commit our changes. Once you commit that, we can go back to our repository right here. If we refresh our repository here, you should see a little brown dot here, and this is actually going to be our workflow file running. So if you click in that brown dot, you'll see the name of our workflow file, and you'll see the check has started. So that means it's going to actually start running. We can click in the details here, and right now we see it running our GitHub Actions step. This might take a minute or two, but you can see here from all the steps, we're getting the authentication token. So we're using our GitHub personal authentication token to actually create that runner. We're also going to generate some RSA key files, and then we're going to create a service file to start that GitHub action every time the container is started. So right here, this setup runner job has actually completed, and next it's going to go to the manage container to actually install all the native dependencies on our container. But what's neat is if we go to settings in our repository, we click on actions, and then we click on runners, you can see right here that this is the runner we just created. And this is not being ran on GitHub. This is actually being self-hosted inside of our Proxmox container. And you can see the status here, and the fact that it's active means that it's currently running a job, and if you click into that, you can see the job that it's currently running. So right now it's actually just running our container management script here, and you can see that it's going to actually start the container creation process, and then it's going to collect all this information right here, all the information that we specified in our workflow file. If you actually navigate to the Proxmox web GUI, under your account, you can click into the container and see it being turned on right here. So this is just my dashboard, but for yours, it might look a little different. But nevertheless, you should see your container here. And even if you're not logged in, rest assured that your GitHub action runner is on here and that it is running and listening for jobs, which is pretty cool. Once the script finishes, you'll get a detailed verbose output here with all the information about your container. So again, your container ID, internal IP, your domain name, importantly, so you can easily access your container, and then the SSH command to get inside that container. It's your container. You can set it up however you want, install whatever you want. This does give you a little bit more flexibility with it. However, it's not going to automatically deploy your application like we're going to talk about in the next steps. Let's say we have to make a new branch for our repository. So if we go in here and we create a new branch, so I'll just name it test branch 1. And I'm going to click create new branch. It's going to create that new branch, but more importantly, if we go back to actions, we can see a new action started right here. And because our branch was just created, our GitHub action workflow knows that we need to set up a new runner specifically designed for that branch. So we have to create a new container with that runner in it. And then from that runner, we need to install the dependencies for our new container. So basically every single branch that we create, it's going to create a new container and a new runner designed to run on that branch. And just like before, it's going to go through the exact same steps. It's going to clone a container and then set up that runner, and then it's going to run the manage container job to install all those dependencies on that runner. And if we go back to our Proxmox web GUI, we can see here at container ID 124 that it's beginning to allocate resources and create this test branch 1. And the naming scheme for all of them is going to be the name of your repository, the repository's owner's name, and then the branch of that repository that the container is based on. And then once it finishes, it's going to give us a verbose output of every single detail we need to actually access that container. And if we go back to our Proxmox web GUI, you can see our container here. One thing to note, and it says this in the purple text here, is additional background scripts may be being ran in detached terminal sessions. So what that means, especially in this case, is if you're unfortunate enough where your container ID is actually an even number, we actually load balance it. So we actually have 2 machines currently, and just to make sure that all of our resources are not on one machine, we may transfer that container or migrate that container to another machine. So as you can see right here, this container is actually being migrated to our PVE2 machine. Because the container has to be turned off in order to migrate, our GitHub action runner cannot be ran. So that's why the script finishes, but you still have to wait about a minute or 2 for this to migrate in order to access your container. But once that's finished, you'll be able to access your container like you would any other container. And we can see here that it's back online. And here, if I go back to list my runners, you can see that I no longer have just one runner. I have 2 runners now, so 1 for each of the branches. It may take a little bit to update, but if it says offline, but you actually see that it's online in the Proxmox web GUI, just give it a minute or 2. It may take a little bit to start it, but once it does, it'll show an idle status. So we walked through what it looks like to actually create a container from scratch when you make a commit for the first time using this workflow. We also showed you what it's like to make a new container when you create a new branch. The last thing I want to show you in this first part is when you delete a branch which contains a container, how it automatically deletes the runner and the container. So if I go to list all of my branches again in my GitHub repository, you can see my test branch 1 here. Let's say, okay, maybe I merge this, or maybe this is just a stale branch and I don't really need this anymore. So all I'm going to do here is just click delete branch. And then right after, if I go to my actions, I can already see a new action being ran. It's going to go through the same workflow, and in the manage container part of this workflow file, this time it's going to run a delete container script automatically. Again, we didn't have to configure this, but it detects that we deleted a branch, so it's going to run the delete container script on our hypervisor to actually begin the process for deleting that container. So if we go into our Proxmox web GUI, it might take a second or 2, but we will eventually see that this container right here, 124 with the test branch 1, will be deleted. And here, if we go back to our Proxmox web GUI, we can actually see that the test branch 1 container is gone, so that the GitHub Actions actually automatically deleted it. We didn't have to do that ourselves. And one more further verification, if we go back to our runners, we no longer see the test branch 1 runner. It was actually deleted with that script. So everything is good, and we are back to normal with just our main branch and our main branch container. Okay, great. So we made it past part 1, and we learned how to configure our workflow file to create bare bones LXC containers from our GitHub repository. For the second part, I'm going to use the same repository, but this time I'm going to automatically deploy it from our GitHub Actions workflow file. And while this may seem a little daunting at first, it's actually not that complicated once you have the workflow template set up, which again, we did in the first part. You just need to add a few more fields so the GitHub action knows how to deploy our application correctly. And these fields are all going to go under the manage container job. The setup runner job is going to be the same. No matter if you're deploying an application or just creating a bare bones LXC container, we're still going to have to set up a runner each time. So that's not going to change. However, for manage container, we're going to add a few more fields. These fields are going to go under the manage container job, not the setup runner job, because that's just going to set up a runner. We don't have to do anything more with that. So I just went ahead and actually wrote all the different fields that we need, but we're going to walk through each of these one by one. So the first additional field we'll need is our deploy on start flag. So if you want to deploy on start, you're going to have to put this flag and you're going to have to set it to Y for yes. The next field we're going to put is the require env vars field, and you're going to set this to Y if your application requires environment variables with special values either to an API key or for a password, whatever it is, you need those in order for your application to run. Now, if your application does not require environment variables, you do not need this field. In fact, for any of these fields that you don't actually need, you can just leave them blank or just not have them at all. If you do need them, then you must put them. If your application does require environment variables and you set this to Y, the next field is going to be the container environment variables field. And in here, you're just going to put a simple JSON piece of text wrapped in single quotes with key value pairs. So the environment variable name will be the key, and then the value for that variable will be the value for the key. In this example, I have an environment variable named API key, and I'm going to set the value to 1, 2, 3, 4, 5, or just 1, 2, 3, 4. Now, if I had multiple different environment variables I need, then I would just put a comment and then put another key value pair, and I would keep doing that for however many environment variables that I need. Now, in my application, I actually don't require environment variables. As you can see, this is just a dummy one, but I wanted to put this here just to show you how you would implement or put environment variables on your container using this workflow file. After you specify your container environment variables, the next field is going to be the project root. Now, this is going to be the directory that you want to deploy your application from inside your GitHub repository. So if you have a folder inside your GitHub repository and you only want to deploy based on the files and folders inside of that folder or at that route, then you would put that route here. But if you just want to deploy from the root directory of your repository, which I feel like 95% of the cases you do, then you could either just leave this blank, put a dot, or just not have this field at all. It's really up to you, but you wouldn't need this field, only if you are, again, deploying from a specific folder. The next command is going to be the actual install command you're going to use to install all of your project dependencies. Now, my project is running in Node.js, so a Node.js runtime environment. So of course, I'm going to use npm to install all of my my npm packages. Next, we give you the option for a build command. If you have to build your project before actually starting it, you can specify your build command here. But again, if you don't need it, you can leave it blank or just not put the build command field at all. We also have the start command. So once it's built or once all of your project dependencies are installed, this is just going to be your normal start command. So for me, it's just going to be npm start. If your project is Python based and you need to start a Flask server or a Django server or whatever it is, then you would just put that start command there. Next is the runtime language, and that kind of builds off these three commands. So if you're using a Node.js runtime environment, you would just put Node.js. If you're using Python, then just put Python here. The next field is the require services field, and this one is really important, especially if it applies to your project. So if your project requires any special services that cannot be installed directly with your package manager, such as MongoDB, Nginx, Apache, any other service that is more container-wide or system-wide that needs to be controlled by your system manager, is loaded as processes in the background or daemons in the background, you would set this flag to yes. So for example, my application requires a MongoDB database, but that needs to be ran across my container. So I'm going to set the require services to Y for yes. And then in the next field down here, I'm going to put services. And inside here, I'm just going to put a array or a JSON array. I'm going to list all the different services that my container requires. Now you might be wondering, well, what services do I put in here? Is every service supported? And the answer to that is there's about 10 to 15 services that we already have mapped. By that, I mean we already have all the install commands needed that will actually run right on your container. And to see a list of the services, if you go to the README file of the GitHub action and you scroll down to where it says services, right here we have the list of all the available services that you can choose from here. So you can see MongoDB here. We also have Meteor, Docker, Postgres, Apache, Nginx, and just some common ones. So those are all going to be placed in here. However, one thing to note is if you have a service that you need, but it's not in that sort of master list, then you can still add it in the custom services field. This field is a little different. It's a 2D array or 2D JSON list, still in single quotes, but for each inner array, you're going to list all of the different commands that you need to actually install that service. So for me, I might need Nginx. but let's just say it's not in that list of services that are supported out of the gate. So I actually have to write all my different install commands here. So first I'm going to update all the packages with apt, then I'm going to use apt to install Nginx, then I'm going to use my system control CLI to enable the Nginx service, and then actually start that Nginx service. So this is just a basic example of how I would install Nginx manually, but of course there's thousands of different services out there, and you might be required to install GPG keys or download different resources. So the commands are gonna vary, and this is not by any means some sort of template for installing any service automatically. So make sure that you do research and figure out all the commands that you need to install that service and put those commands here. And also make sure to enable the service and start the service at the end for it to automatically start when the script is ran. All right, so we went over all of the different fields that we need to get a single component or a single service ran. So now we can just commit this workflow, and hopefully, if everything is right, our main branch, since this is what we're committing it to our main branch, all of that code will be automatically deployed to our container. So let's try it out. So I'm just gonna commit my changes here, and I'm gonna push this to my origin. Now, if I go back to my repository on my web browser, if I reload it, we can see another sort of brown dot here that shows that another GitHub action is running. If we click into this on our main branch, we could see the workflow. And because we already have a runner set up from the first part of this video when we did this, I'm gonna skip this step and just automatically use that runner to run the second part of the workflow file. So when we go to the manage container job, we can see that it's going to do its checks. It's going to make sure that the container exists before it tries to modify it or install different dependencies. And here, because our container already does exist, it's going to automatically run the update container. All right, so we see that the GitHub Action script has actually completed, but it's not quite ready yet. Again, it's going to be running those background processes for migration if needed, as well as creating a template clone internally. Just wait a minute or two just for all the background processes to finish. All right, so after about 20 seconds, the container is back online. So let's just go to the URL for our container. Again, it's just the container name.opensource.mieweb.org. And I have no idea if this is going to work, but since we're automatically deploying it, it should. So if we did everything correctly and we press enter, yes, so we can see the application here. So I never actually had to SSH into the container. And just to make sure that the MongoDB database is working, I can just create a test account here, put in a random email, and then if I click register, you can see here that it actually sent that data to the database and registered me. So in terms of this application, everything is actually deployed, which is awesome. So now we're ready to move on to the next part. Now, let's say we're implementing a feature request. So we're going to make a new branch, and inside that branch, we're going to make some changes. Let's do this and see how GitHub Actions creates a new container with our changes. So as you can see, I created a branch called pull request. Now I'm going to git checkout to that branch. Just to make a simple change, just for the sake of demoing, let's go to our index.ejs folder, and inside we'll say collaborative decision maker pull request. Now let me commit this. When I push this code, because it's on a new branch, the GitHub Actions workflow file will automatically detect that and create a new LXC container on Proxmox. Now within that LXC container, it's going to clone this version of the repository. That means when I navigate to the link for that container, I'm going to see the header collaborative decision maker pull request. However, I'm not making any changes on my main branch, and thus no changes will be represented on my main container. So that way we'll have two different containers with two different states of the application. So let me push this. All right, so I pushed those changes. So let's go back to our GitHub and let's see if we can see that action being ran. So we can see that new action starting, and it's going to actually set up another new runner for us. We can see here that we do have the pull request branch. So we know we committed our changes correctly. So let's just wait for the setup runner job to finish and the manage container job to finish. Now, another neat thing that unfortunately you won't be able to see, but when that new branch container is being created, it's actually being cloned from a template. So if you take a look at template 124 on my Proxmox dashboard, you can see template rank room max clemma. So that's actually a template that it created from the main branch that we created just a little bit ago. And the whole point of this is to help try to speed up that process of cloning new containers and creating new containers, since this template already contains that GitHub repository and all the dependencies for the project. So all it really has to do is just a git fetch and a git pull and just update any new services processes, and it's good to go. So this makes creating new containers a lot more efficient. All right, so our script just finished and we now got the container details for our new container. Inside our Proxmox web GUI, we can see that the container is actually migrating to another hypervisor because it's an even number. So we'll give it a minute for that. But if we go into, again, the action runners, we can see that we do have another runner, but this time it's for the pull request branch. Now for the fun part, if we just type in the link that script gave us in the GitHub Actions and we click go, we should see our new changes here. So remember when I put pull request in the header? Well, here it is right now. Let's go back to the container representing our main branch and let's see if those changes were reflected there. So I'm just going to go to this other tab and you can see in the URL that it's for my main branch. And if I just go to that home page again, you can see in the header that I don't have that pull request tag. And then here I do, and I'll even refresh this again. So the whole point is just to show you that each container representing each branch maintains its own version of the code base respective of that branch. So this just makes it very easy to show and view pull requests and different branches at a glance instead of cloning it onto your local machine. Okay, so now what I want to do is I'm going to take that pull request branch and I'm actually going to merge it into my main branch. So if I just open a pull request here, there might be merge conflicts. So we can, okay, no merge conflicts. Great. All I have to do now is actually just make the pull request, and it's going to take my changes from the other branch and apply them to my main branch. However, the branch that I'm merging from, which is my pull request branch, will be deleted, and those changes in the main branch will be reflected in the main container. So I'm going to confirm this merge, and I'm just going to go to my actions here, and we can see here that an action has already begun that is going to update the main branch. And just like this, we can see the update container script running. So we'll leave that alone. So now what we can do in the meantime is actually remove that runner and that container from that old branch that we just merged from, because we no longer need it. If I actually just go ahead and delete the branch, we can see another workflow has automatically spawned, and this time the workflow it's actually going to delete that GitHub runner for the pull request container and delete the container itself as well. So if I go back into my Proxmox web GUI, you can see the container was actually just deleted off my screen from the pull request, so that's no longer there, and that the main container is updating. So let's give it a few seconds and we'll wait to see the changes there. So the container has just reloaded. I can see the metrics starting up here, so I think it is good. So let's go ahead and refresh the main branch here. And as you can see, without actually entering the container, everything updated from that pull request. So when I merged it, the main branch automatically updated, and then we deleted, well, the other branch in the container was deleted automatically as well. So all is good without actually having to SSH into any container and do this. And just for good measure, if we check the runners, we can see the pull request runner is gone too. So now we are in the final part of the video. This time it's going to be for an application consisting of multiple components or multiple services or processes that are actually running in parallel or concurrently. So for this repository, for example, I have a backend that's written in Flask or Python, and that has a few different API routes. And then my front end is actually Invite, so that's a Node.js runtime environment. So those are two completely separate frameworks, and they run on two separate different processes. But I need both of those processes to run concurrently in order for the application to run. Unlike in part 2 of the video where I had a single component app, for each of those fields in the workflow file, I would only put one command, so npm start, npm build, npm install. But for this one, or for apps like these, it's a little different because you have to specify a command like that for each different component, and we can do that actually using a simple JSON template, and I will show you that right now. So here I am. I actually cloned the repository that on my local machine, and now I am in the container management workflow file. Again, if you just skip to this part, I do recommend watching the first part and the second part too, because I go over basically every single one of these fields. There are a few new fields here, but I do recommend watching those just so you're familiar with the setup that we have so far. So if you've watched those two parts and you understand most of these fields, you'll see that some of them are the same and then some of them are a little different. So we still have the deploy on start field and we still want that to be Y. However, a new one is a multi-component field, and that will tell our workflow file that our application consists of multiple components. That's very important. We also have the require env variables field, and we're going to set that to Y again, just like last time. However, this is where that JSON template notation comes in handy. Unlike before where we just had sort of a single layer or like a one depth JSON object where it was just key value, key value, key value, you can see that it's sort of 2 layers deep, where we have a key and then that key represents the component path. So here, this key right here is the front end. So all of the environment variables that I want in my front end, or for my front end, so my Vite front end server, I'm going to put in another object here as the value. So I have my front end, and then the value here will be another JSON object. And inside there, I can put my key value pairs, as many as I need. So I just put a dummy test front end key value here, and then the value would be 1, 2, 3. And it's similar with my backend. So for my Flask server, I might need a variable called test backend ABC. But the whole point is I put the route to that folder, so front end, and then backend. You don't need that backslash at the end. But these variables will only be placed in my backend folder, and these will be placed in my front end folder. And just to verify these routes are correct, if you look in my folders here for my repository, at the root directory, I have a backend folder, and then I have a front end folder here. And then I don't think I actually specified the root directory field here, but if your root directory field is left blank or it's empty, again, it's going to assume that it's at the root directory of the project. However, if you do specify the root directory to be somewhere inside your project, you have to ensure that these value pairs or these key pairs for these directories to these components are relative to that root start command. Now, if you look down here, you can see that my project root is just at the root of the repository. So therefore, all of these paths, so all of these key pairs to these directories are actually absolute paths. However, if this project root was not at the root directory, but in some sort of inner folder, then these values would be relative to whatever this project root is, and these wouldn't be absolute anymore. So if that's the case for your project, just make sure that you're careful with the file paths. Next, we're going to look at the install command. And again, it's in that sort of similar looking JSON object format as the container environment variables. The only difference is that the values are not actually other objects. Again, they're just simple strings. So again, we have the front end, we have the back end keys, those are just routes to our components. And then as values, we have the actual installation commands. So for my front end, I need to use npm install to install my dependencies. However, for the back end, I need to use pip, and I'm actually using a requirements.txt file. So I'm going to specify the route to that requirements.txt file, install all of those requirements recursively. As you see here, I actually go up a directory because in my backend folder, as you can see in here, when I'm in this folder to access my requirements.txt file, it's one directory up. So I have to do that // requirements.txt. Build command, it's the same idea as the install command. You have a key value with the value being the build command for the component. I don't have any build command, so I'm going to skip this or just put an empty object here. Start command, again, the same idea, key value being the route to the component, and then value being the actual start command. So npm run dev or Flask environment deployment, set the environment variable, and then run Flask run to start the backend server. The runtime language is the keys are the same to the component. The values are going to be the actual runtime environment. So the front end, again, it's running on Vite, so that's going to be a Node.js runtime, and then the backend Flask, so of course that's going to be a Python runtime. And then you still want a services field with the list of all the different services that your project repository requires. Again, if the services are not listed in the README in our Proxmox Launchpad repository, then you're going to want to add a custom service here where you just have to specify each of the installation commands to install that service, and also use system control or your system manager to enable and start that service. Another field that's actually new in the multi-component aspect of this is the root start command. So if you have multiple different servers or multiple just different components in general, each with their own package managers and then package list and all that, you still may want to run a start command or just some command at the root directory. And I find this most common if you're using Docker. So if you're using some Docker Compose command where you, after you've built an image and all of those services start within your Docker Compose, that might be a good use case for something like this. And this is not required, but it is nice just to have it. If you do need to run a command or commands, you can use two ampersand symbols to run at the root of your project. And then lastly, don't forget to include your GitHub personal access token. So I would store that as a repository secret. And then create runner job, we're going to specify that to N for no, because we're not actually creating a runner in this step. And then in terms of the runner, everything is the same. All of this is the same as in the first and second parts of this video. Now that everything looks good in our workflow file, I'm just going to commit this to our repository. So I'm going to push these changes. Everything's good. Now, if I go back to the home page of our repository, we can see that we did commit those changes successfully. And again, we get that brown dot indicating that a check has started, and it's going to be our workflow file, of course. And the first step is going to be the same as in the second part of this video. It's going to set up a runner, and then it's going to manage a container. Also, I try to make this video where everything was running smooth, but sometimes you will get errors in the workflow. I do my best to actually sort of explicitly say what it is, but in this case, we can see that it is authentication failed. So when it was authenticating into our Proxmox account, it just was not successful. So make sure that your credentials are up to date and all the fields are valid, else you might get some sort of error and your workflow will fail. So in my case, I just did a little bit of digging, and it turns out that I used 2 different usernames in both of these jobs. Just make sure you're using the same Proxmox credentials in both of these steps. So I'm just going to push this commit again, and if we go back to our repository, we should see that a new action has started, this time with the updated workflow file, and hopefully we actually, yes, so our Proxmox account was authenticated this time, so hopefully everything else goes smooth. All right, so our GitHub Actions workflow just wrapped up. It gave us all the details for our container, and it gave us this domain link, so let's open it and let's see if our container automatically deployed. So I'm just going to open this link in a new tab. And down here, we can see that it actually deployed. Now, the reason I'm getting this blocked message is in my Vite config file, I actually have to add this domain to that config file in order for it to actually display the application. So let me do that. So I'm just going to go back to my VS Code session here, and then in my Vite config file, I'm just going to change this, and then I'm going to recommit this. Now, if I go back to my repository, if I go to the actions, I can see that an action has started to actually update the main branch. So this is actually a good case to show you that this multi-component service or this multi-component application, again, will update automatically on every single push. All right, so the update workflow actually just finished. So now let's reload our application and let's see if we're able to view it now. And we can see that we are here, that from this demo that both services are running concurrently or in parallel to power this application. Now this time I'm going to make a new branch and I'm going to call it pull request, and then I'm going to get checkout to that branch. Now that I'm in this branch, I can just go to my index.html file and we can just change whatever we want just to show that this container is going to have a different version of the code base than the main container when we push this branch. So maybe I can just add a new h4 tag and say is exclusive to the PR. Anything simple like that. And I can even go into my backend and then I can change the message that is returned when making a request to this endpoint. So maybe instead of saying template, I can say pull request. Awesome. So now that I've made just some simple changes, I can go ahead and commit these. And once I actually push this code to my repository and I refresh the actions page, you can see that a new action has started. And this time, again, it's going to set up a new runner. And then once that runner is set up in my container, it's going to use that runner to allocate the resources to this container to install the new dependencies and actually automatically deploy both of these services concurrently. So we'll wait just a few minutes for this to start. All right, so the update action actually just finished and it spit out this URL. So let's open this in a new tab and see if the changes took effect. So I'm just going to open this link in a new tab here. And we can see, boom, all of our changes are here. So we have the pull request from the backend Flask server that we requested from. And then we also have the text that we hard-coded in related to this PR. Awesome. So now if we go back to the original container that's hosted on the main branch and we just refresh this, we can see that everything is still the same from the main branch. So again, just like in part 2 of this video, each of these branches or each of these containers related to each of these branches have their own separate version of the code base, which comes in handy when you want to review different feature requests and just different versions of the code base, especially before merging a pull request. And the last thing we're just going to do in this video, just to wrap up, is we're just going to delete this branch and we are going to go back to actions and we will see that the new workflow file has started to actually delete that runner for that pull request on that container, and then it's actually going to delete the container itself. So again, this is good for after you've merged a pull request, or if it's a stale branch and you just don't need it anymore. So let's just wait a few seconds for this to finish, and we'll make sure that the branch was deleted. I go back to my Proxmox web GUI. I can see here I used to have a container 136 with the pull request, and now that is gone. And waiting a few more seconds and then going back to our runners, we can see that the runner no longer exists. So that about wraps it up for this video. Thank you for watching. Hopefully my explanation helped for all 3 different scenarios, from deploying a bare bones container to actually automatically deploying our applications, whether it's a single component or service, or it consists of multiple components or services. So no matter how your repository is set up or what services you're actually running, the goal of this GitHub action is to be flexible to support all those different kinds of applications. This is still an early version of the workflow. I'm going to be trying to squash as many bugs as possible. So if you do encounter some bugs, rest assured that I will be fixing them and updating this continuously. Yeah, thank you for watching. And if you have any questions, please feel free to reach out to me. Thank you.